Yes, section 8.3, we're going to graph general rational functions. Basically, last section is simple rational functions like y equals 2 over x. There's a simple rational function, and those have certain asymptotes. And now we're going to deal with more complex ones, which have different asymptotes, different domain of range, all that kind of stuff. So let's look into some notes here. Took this out of the book. Basically, here's the key right here. F of x equals p of x over q of x. Now, this looks like a lot of stuff here and people don't understand, but basically here's what we're looking at. The function equals something, some polynomial, like we'll say 5x, over some other polynomial. We'll say x squared plus 1. Let's go minus 1. It'll be easier. X squared minus 1. Okay? This is my rational function. Why rational? Because it's a fraction. Okay? So it says let p of x and q of x be polynomials with no common factors. So here's p of x, the top. So basically, as soon as it says p of x, that's the numerator. As soon as it says q of x, that's the denominator. Okay? So let's kind of switch those words up within here. The x-intercepts of this graph, of this thing right here, are the zeros of p of x. So basically the zeros of, what's p of x? P of x is the numerator. So take the numerator and find the zeros of it. And what do you have? You have your x-intercepts of the graph. Okay? So what is the zero of that numerator? Well, all you have to do is set the numerator equal to 0. So 5x equals 0. So there is a 0 at x equals, divide by 5 on both sides. X equals 0. We'll just write that here. X equals 0 is a 0 of the numerator, which means that's an x-intercept right there. So you just label that x-intercept. Then we go to number 2. So there's 3 things you always do whenever you come to these more complex rational functions. Number 1, find the x-intercepts. How do you do that? Set the numerator equal to 0 and solve. There you go. Answer. Number 2, this graph has a vertical asymptote at each real 0 of q of x, which q of x is the denominator. So all you have to do is find the 0 of the denominator, which, just do this. Set the denominator equal to 0. X squared minus 1 equals 0. So x squared equals 1. Move 1 over. Square root, x equals root 1 is plus or minus 1. So x equals plus or minus 1 is from your denominator. So that means these are vertical asymptotes, VA. Alright, here's your asymptotes. Since there's 2 of them, that means you're going to have 2 asymptotes going vertically. Here's your x-intercept. Here's your vertical asymptotes. Lastly, number 3, this graph right here, has at most 1 horizontal asymptote. So it could have as many vertical asymptotes as there are zeros, but there's only going to be at most 1, which is determined by the degrees, m and n, of p of x and q of x. So what this really means is this. Find the degree of, what's this mean? The numerator. Find the degree of the numerator. So up here, what's the degree of this numerator right here? The highest degree is, this is x to the first. So degree of the numerator is 1. So degree equals 1 up top. Find the degree of n. N is the degree of the denominator. See this? Here's what it is. M and n. What's the highest degree of the numerator? Right there. M. 1. What's the highest degree of the denominator? Which means highest degree of q of x, which is denominator. We'll look at it. What's the highest degree? Well, x squared. So degree of this one is equal to 2. So degree of the top is 1, degree of the bottom is 2. Now look what happens. Here's the chart that you have to memorize. If m, write this down, m is the degree of the numerator, and n is always the degree of denominator. So if the degree of the numerator is less than the degree of the denominator, this is what happens. Y equals 0 is an asymptote. What if that's not true? What if the degree of the numerator is equal to degree of the denominator? Then whatever these two numbers are, this divided by this is a horizontal asymptote. I'll get to that one later, what these two things are. Basically it's the coefficients, okay? 5, whatever that is. This is 5 and this one is, it's a 1x squared, so 5 over 1, if that was true, but it's not. Lastly, the graph has no horizontal asymptote if the numerator has a bigger degree than the denominator. So write a little example of this. Y equals, I don't know, x squared plus 1 over x, we'll say. The degree of the numerator is bigger than the degree of the denominator, which means no horizontal asymptote. So there's always 3 cases. So I need you to memorize those 3 cases and you'll be fine. So there's a lot of stuff in this. So quick recap. Number 1, find the x-intercepts by find the zeros of the numerator. Set that equal to 0 right there. Here's my x-intercept. Number 2, go to number 2 then. Okay, how do you find vertical asymptotes? Basically, set the denominator equal to 0. We did that. Set denominator equal to 0, and we found these answers, plus or minus 1. Those are our vertical asymptotes. And then number 3, all we have to do is look at the degrees. The degree of the top is 1, degree of the bottom is 2, 1 is less than 2, m is less than n, so therefore this case applies, which means number 3, the horizontal asymptote is y equals 0. Alright? So that's how you kind of use these rational functions right here. Let's get to an example. Graph this rational function. So look at this right here. Number 1 on that list was, let's see, find the x-intercepts. How do you find the x-intercepts? Basically, take the numerator, make it, find the zeros of the numerator. Now, this is tricky and easy at the same time. There's no x up here, so you can't set 6 equal to 0. That doesn't make sense. Okay, so therefore, there are no x-intercepts here. Okay, because there is no x up here. There is no zeros of 6 by itself. Okay, so number 1, no x-intercepts. Go to number 2. There's only 3 things to do. Number 2, basically find the vertical asymptotes. Okay, what is this equal to? Well, all you have to do is set the denominator equal to 0. X squared plus 1. So x squared plus 1 equals 0, which means x squared equals, move that over, negative 1, square root, what happens? X equals plus or minus square root of negative 1, if you remember, is the imaginary unit I. So here's your vertical asymptotes. They're imaginary, which means you don't have any. You don't have any real asymptotes. So there are no or none, no vertical asymptotes. Okay? Because this happened. If this was a normal number, you'd say, oh, these are my vertical asymptotes, but it's not. Number 3, last step, based on those notes you just took a minute ago. This actually can be really easy if you know those notes, that last slide. Please understand it. All you have to do is check the degrees of the top, check the degrees of the bottom, and then decide, is m less than n, is m greater than n, or is m equal to n, and then memorize the case. Okay, in this case, look at this, there's no x up here, which means it's really like x to the 0 power, because there's no x's. There's x to the 0, and there's x squared. That's the degree. 0 is degree up top, 2 is degree of the bottom, which means m is less than n. What's that case? it says the line y equals 0 is your horizontal asymptote. That's what it said in the notes. So here's the deal. You have to figure out these three things. What are your x-intercepts? Set the top equal to 0. Can't. None. Number 2, vertical asymptotes. Set the bottom equal to 0. That's I, so there are none. And then thirdly, memorize that chart. It's either this, this, or this. Memorize. In this case, y equals 0 is horizontal asymptote. Now, what I want you to do is, I do want you to graph this section. But you're going to get your coordinates from your calculator. So type this in your calculator and go to your table and watch what happens. I just showed it to you. You're going to find coordinates. I want you to start plotting coordinates. Alright, here's one, here's a coordinate, here's a coordinate, here's a coordinate. Now look what happened. When you drew this thing, or when you do draw these things, if you followed it, notice what happens. It'll never touch the x-axis, which means, what is the x-axis? That's y equals 0 is the x-axis right here. That's your horizontal asymptote. You already figured that out. Okay, was there any x-intercepts? No, look at this thing. This will never touch the x-axis. No x-intercepts. Number 2, are there any vertical asymptotes? Anything, can I draw lines straight up and down? It would never touch. No, it touches everywhere. It goes left, it goes up, goes down, it goes right. There are no vertical asymptotes. So this is the key. Making coordinates is the key to this type right here. So example number 1, if m is less than n, well, this is just one case of m is less than n. Could be other types. So just be ready for any type. Alright. Alright, the other part of this, these examples is you always have to find domain or range. So, how do you find domain? How do you find range? Well, sometimes it's easy to look at the picture and check it out. I mean, look at this one right here. It'll never touch the x-axis. So, basically everything is from here, from the x-axis, up. So between up and down, you know, your y's, well, it starts here and goes up. So all your y values have to be greater than, should it be equal to? No, it never touches here. So just greater than 0. Everything above 0, all your y values. That's your range. Now your domain, look what it does. It goes the whole way to the right, up, goes the whole way to the left. So if you're looking left and right, everything is covered. Everything. So your domain in this case is all, can't spell all reals. Now how do you tell that just by looking at this? Well, what could x be? That's what domain means, right? What could x be? Anything. And you put anything in there, you square it, it's going to be a positive number, right? Even if you put 0 right here, 0 squared, that's 0 plus 1, that's okay. Remember, the denominator can't equal 0, right? That's the only thing you got to worry about. So, in this case, though, domain all reals, range y is less than or greater than 0. So,